James, thanks for joining us. I was really looking forward to this presentation, especially after your last demo that you posted online. So I'm really keen to hear a bit more about it and what you are doing. I think you can get started with sharing your screen and yeah, let's get cracking.
Great, sounds good. Welcome. So yeah, I'm James Turnshek, Chief Architect at a company called Formant, and I'll use a little bit of visual aids, but I'm not gonna like show a bunch of slides or something like that. Just have a few things. So we're Formant. You know, our goal as a company is to make it so that people can run fleets of autonomous robots, which sounds like a bit of science fiction. I think I've talked to a lot of people who either sort of assume that it's already happening and people already have giant fleets of robots everywhere, you know, doing various tasks, and then talk to other people who sort of feel like it's, you know, completely science fiction and no one's ever going to do it, and all of robotics is really all about, you know, making one thing that works really well, or sort of like you know, inventing new mechanisms and new types of autonomy and things like that. But we're really built to assist these companies that are, you know, their whole goal is to have, you know, thousands or hundreds of thousands of systems running in the field and have some sort of way to do some task. So I'm going to kind of talk about first, like what exactly makes up those kinds of companies, because I think it's a very important thing that is pretty new, and I think most of the robotics industry is not exactly like up to the modern era when it comes to, you know, thinking about how to build businesses like this. As I'm going to talk about that a little bit, and then I'm going to talk about you know, Formant and what we do and how we help people, and then you know, I assume that there'll probably be some questions that I can take. So yeah. So first, you know, who are we? So we're about 20 people based in San Francisco. We started about 4 years ago now. I'm in Pittsburgh, Pennsylvania, on the East Coast, United States. We kind of have about 20 folks that are split between San Francisco, Pittsburgh, Denver, and Portland in the United States. We have one guy in Italy, but mostly US based. We have customers that are all over the place. You know, really, as a company, we're very much, you know, made up of people who have worked at these fleet robotics companies, or people who have worked at big cloud providers, or people who have been involved in various kinds of like interesting user experiences, because we're very user experience focused as a company. Jeff Linnell, my partner, started the company, you know, 4 years ago or so, and then he acquired my teleoperation company about 2 years ago, which is, you know, how I came on board here with my team, and then we've kind of been running this together since then. So as far as, you know, our history, you know, it really sort of started with a lot of Jeff's kind of vision around what the future could be like here. Jeff previously ran a company called Bot and Dolly, which some of you guys might be familiar with. There's a short clip of what they used to do. Hopefully interesting. Jeff brought a lot of the kind of culture of that into Formant when he started it. Bot and Dolly was actually acquired by Google when they bought Boston Dynamics and a bunch of other robot companies back 6 or 7 years ago. And then he, to start Formant, basically took his team out of Google X, where he was running robotics, and then we started the company there. So a lot of that kind of continues into our culture here, and we end up doing a lot of other weird stunts often that that end up being sort of contributing to this whole concept of what we're doing together. This was an event that we did with Twitch about 6 months ago now, where they built a maze in our office in San Francisco and then used our software to run a bunch of spots through it so that professional gamers could compete in a local environment. But remotely. So we get involved in a lot of weird stuff like that. But as a company, what we actually do is we help all of these companies that are running essentially these fleets of autonomous robots. So about half of these are current customers, but we're under NDA with a lot of them, so I can't always say which half. But the gist of it is that essentially there's this new way that people are building really high growth, like high scale robotics companies, and it's that they don't start out thinking about them as robot companies basically. A lot of these companies, like this, the second one in from the top, on top row, second one in from the left, is a company called Canvas. These guys sell drywall, mudding, and sanding services, and realistically, their customers don't even think that they're buying robots or robot services or anything like that. They just have a section of drywall in an office building that has to be sanded, and so they hire a company to come and do it, and they come and they do it with robots, and they manage the robots on site and remotely, and they diagnose them, and the objective is eventually you get to the point where you can have a pretty much fully automated system. The trucks pull up, the robots roll out, they do the drywall everywhere, maybe they do other things on site, and then that's the end. And these kinds of companies are really extremely sort of like economically fit to operate in the world as it is, because people are already used to buying drywall services. People don't, construction companies don't know how to manage robots. They don't know how to service robots. They don't know how to improve robots. It's hard for them to come up with an ROI on buying a robot, because it's sort of a long-term investment, and who knows how it's going to last, and then are you going to want to upgrade at some point? All these are very complicated calculations, and realistically, what I think people have found is that it's tremendously easier for a company to sell what is essentially a traditional service, like drywall or crop weeding or delivery, or street sweeping, one of these things, and then actually to fulfill the service with some robot system that they've come up with. And then all the robot systems are essentially semi-automated. Maybe they can perform for a week by themselves. Maybe they can perform for a few minutes by themselves, or even less. Like a lot of the delivery robot companies, I think I've talked to some of the people on Slack about this, like a lot of the delivery robot companies, they can't actually drive across a street without handing off to a teleoperator. And so, they're in the situation where they might have hundreds of robots out in the world, but realistically, they have teleoperation centers, and then the teleoperators jump in remotely, drive across the street whenever it's necessary, and then head back off to autonomy. So this kind of like combined autonomy, with a system that mostly is autonomous and has remote assistance, is actually like a very valid way to grow within an industry like really quickly. And the cool thing is that if you actually solve the autonomy problem or the hardware problem, you can potentially solve it for the entire industry, right? Like if, one of these delivery companies actually solves the problem of autonomously delivering in a city, on sidewalks from point to point, realistically, they can do all the deliveries in every environment that looks similar, right? Which might be all of the United States and Europe, or something like that. So, it kind of has the benefits of software where if you're adding to a system and building on it over time, that system can kind of scale to any scale. So, one thing that this really changes is the economics of the robot company itself. So, if you're a company that makes carts that can be used for deliveries, you kind of have to figure out how to run a business around selling those carts. And you have to find the customers who are trying to buy robot carts for certain things and all of that. But the right boundaries that I think these companies have kind of found is generally they pick a service. So they say, I'm going to do raspberry picking or something like that. And then they say, okay, well, raspberry picking, that's going to require certain robot morphology. That's going to require certain navigation abilities, certain manipulation abilities. I'm going to build this custom hardware that works with it. And then I'm going to automate that hardware for this task. And so really, what we've kind of seen is that almost every individual task that's pretty easy to draw like a circle around, there's some company or usually many companies out there that are trying to actually solve that autonomy problem. So, where we come in here is that we run infrastructure for these companies, software infrastructure. So we don't do anything in the realm of hardware, and we also don't do anything in the realm of autonomy. We kind of consider that hardware and autonomy are both pretty application specific. So this is, something that really only makes sense to do for a specific task. Sometimes there are sort of components that you can pull together to solve a task with hardware and autonomy. ROS has made it really easy to get an autonomy system working in indoor spaces, at least, for sort of basic things. And you combine ROS and move it with some customization, you can get a system that can do like a lot of navigation and manipulation tasks kind of out of the box. For hardware, there are pretty good mobile bases, arms, drones are really, really nice now. And a lot of these tasks only need things like taking pictures of something, right? We have companies we're working with that do railroad inspections where you fly a drone down a railroad track and take pictures of everything, and you just have to do that once a day. So any of these things, it's sort of generally you can kind of assemble something. You probably don't have to build your own custom robot right away. And in general, most of the companies that we work with, when they're first getting started, they kind of raise their first round of financing or sort of whatever with just market economics. So they understand what they're targeting in the market, how big of an opportunity that is, and then sort of ideas around how they're going to build a robot system. So, but the fewer things you actually have to make from scratch, the more likely you are to succeed. So then where we come in is we come in and plug in basically the whole cloud backend. So this is, everything from teleoperation through recording data into the cloud and replaying it and seeing what's going on through analytics on top of it. And then like connections to the rest of your software systems. So I'll kind of pause there for a minute. So this kind of gives context, and I can jump in and kind of give a bit of a product demo because I think it's somewhat interesting to kind of start out with. So this is our platform. Here we have an overview page. This is really like sort of our internal robots. There's about 60 connected to this organization. Probably half of them are broken, realistically, as test robots tend to be. But I can go ahead and I can jump into sort of any one that I want. So here, this is one of these Boston Dynamics robots that's online in California, so across the United States from me. And it's what we have here is essentially our observability view. So this is where we have media streams coming in. We have all kinds of different telemetry data coming in, as well as sort of arbitrary stuff like JSON payloads, states that the robot's in. But it's really kind of anything you want to see here. And all of these, generally each system is going to have a couple different dashboards that you configure it to have. And they're kind of configured by type of system. So if we go to something else, we might see that, this one here has a different layouts depending on what what we want to see or what kind of user we are, all of those sorts of things. So if I jump back to this guy, I can also come in here and see all of the events that have happened recently. So in this case, the blue line here on the timeline is when the robot's online. We also have these little tick marks that show us things like teleoperation sessions that someone has run. If we want to see configuration updates, they're called out here. Comments that people have left, and also things like annotations that people have added. So in this case, I might want to say that this period of time here had a multi-floor outdoor survey run or something like that. I guess that's what annotation is configured here. And I can pick that. And this data can be sent on to a machine learning system or recorded for analysis, things like that. So this, this is kind of, it's a combination of root cause analysis workflows for the sort of so sort of the support staff for the robot, but then it's also things like all of the, realistically all of the working with the data that you're getting for various purposes. So I can also jump in to anything that's online here. So right now, instead of looking at the data that was recorded to the cloud for this system, I'm jumping in and actually teleoperating it directly. So here, if I want to, I can kind of dance with it in place. It's actually currently, you can tell there's a little cord hanging out of the back of it there. So we have it tethered in place, which is going to make it so I can't run around with it. But if I want to switch to the front camera here, you can see what the environment looks like. Here you can see there's some cameras over there on a sliding rail, and it looks like someone's sitting back there watching. But this is the type of interface that you can construct if you want to, remotely operate a delivery robot, or people switch between different modes to do inspections or to do manipulation tasks, or really it's kind of whatever you want. I mean, a lot of people actually use these modes just to sit there with a soft e-stop, so that if a system gets into trouble, they kind of know right away and they can cancel it, or just to get a real-time video feed from a bunch of different cameras of something that's going on. But the whole platform is really very composable. So what we try to make it easy to do is just build up interfaces like this, or like the observability dashboards, or any of that kind of stuff, so that you kind of have the interfaces you want, and you didn't have to do a lot of web development and manage scalable Kubernetes pods and all of that sort of stuff, just to be able to have these kinds of systems. So the other piece here is the analytics. So, it's not quite as fun to look at, but this is where we can kind of take all the data that we are pulling in from the robots and run aggregations on top of it. So we can see things like how productive a system is over time, or what its average downtime is, or how many handoffs the autonomy system had to have, or just how many strawberries or whatever did you pick that day. Seems like that one maybe doesn't actually have data in it. Well, we'll see if, I guess maybe these queries haven't been refreshed in a little bit. There we go. So but this is, this is in general, it's one of the kind of things that people need to do is figure out what the high level characteristics of a system are. Oh, there we go. So this was actually the people who played with our Play with Spot demo last week. And so we actually got about 3,000 unique people over the span of a week that played with it, which I think probably makes this Spot the most teleoperated robot of all time, is my guess, when it comes to the number of people who actually got to drive it around a little bit. So, with this, we have everything that it takes to actually, configure this, set it up, distribute and manage configuration, manage commands and payloads and files on robots, and all, all the sort of stuff that you might imagine is sort of necessary to kind of configure the infrastructure. But realistically, at the end of the day, you kind of get something that has a series of dashboards like this and makes it possible to, essentially run a whole fleet remotely for lots of different morphologies. So, and that's essentially, what we sell, right? Is that people subscribe to a service and they can use certain components of this, and it's based on what they need, essentially. And so, we'll have new companies come on and sort of onboard them, have, maybe a couple of robots at first, and then they'll sort of grow to big fleets. And, oftentimes we also get companies switching over that already have sort of large fleets of robots, and they're swapping out their backend infrastructure for our stuff because in many cases it's a lot more modern. A lot of people's infrastructure, they've sort of grown from something that, was just kind of a hack at first, and then it kind of kept growing and growing, and it was never really truly sort of like considered or overhauled. A lot of it is actually initially on-premise servers that they use to operate the robots, that then they put the on-premise servers in the cloud. Then they have sort of multiple cloud on-premise servers, and they're in kind of a bit of a pickle. So do a lot of infrastructure modernization for those companies. Then our other types of customers are the sort of enterprise companies, which are creating sort of internal centers of competence around managing robots. So, in this case, BP, for instance, is a customer of ours that they use us to manage spots and other, robots to do inspections. And so, they actually have a ton of robots at BP, and they're, getting everything sort of sorted into a place where they can have one group that manages them all. So that kind of covers the initial, who am I, what are we working on, what do we do, what is the tool like? It's sort of like a very fast overview. Maybe I can pause for a minute and see if anybody has questions about anything.
Okay, 1 second. I will allow everybody to unmute themselves. Yeah, so now everybody can unmute themselves if you have questions. I have one. Can you, do you have some, so all of these work as widgets, right?
All of these work as, yeah, so basically, this is a flexible dashboard. We can edit the dashboard to add different streams from the devices, change the layouts, and then we can add multiple dashboards per device.
Okay. And do you support anything like, I see you have location. Mm-hmm. Do you support, for example, plotting the odometry? So, for example, I would like to have the map and show where the robot walked, so the path the robot has taken, for example.
Yeah, so we've got a couple different ways that we do that, both indoor and outdoor. So, if you have maps and things like that, we'll give you a map with paths and plot your plan, plot your trained routes, all of that sort of thing. And then you can issue waypoints to the map to move a robot around. We're actually just in the process of working on our GPS map editing so that you know, a lot of the companies that we work with, what they'll do is they will have a system that you train using like a teach and repeat method. So Spot actually works like this, right? So you can say, I'm going to drive you around a space. And even with the pan tilt zoom camera, you can say, I'm going to take pictures of these things while I'm driving you around, and I'm going to train that route and save it. And then I'm going to just say, repeat that route, and it'll actually, you know, manage to run the same route. Even if it's in a different place, it can adjust the PTZ location so it can still take the right pictures of things. But the problem there is that a lot of times you sort of train a route and then you realize it's a little messed up. I have to go around something here, and now it's always going to think I have to go around that, even though it's not there anymore. I wish I could just go in and manually edit it. And you know, right now, what most people do is they use like Photoshop, basically, to edit a map and then re-upload it to the robot. But we have a whole set of things coming out that's going to make that a lot easier for people.
Nice, interesting.
Hi, James. Thank you for the nice presentation. I too had one question.
Sure.
In continuation to the previous one. So currently, I assume that we have to provide you with the information. You would be doing the plotting, right? So in which case, how do can we define customized KPIs? Like, you know, if it's a teach and repeat method, then for a particular map, how many stops did it have, or across different machines? If there are 10 machines in the field, and then you want to know which machines actually not working fine. So like that kind of a dashboard, is it possible to customize?
Yeah, absolutely. So that's where we put a lot of the what we do for a lot of these analyzed dashboards. So these queries, I think, actually just recently got very large. So this is like taking a while to fire. But essentially, what you'll do here is you'll pick streams and you'll pick the types of aggregations that you want to run on the stream. So for instance, you know, you can say something like for the state stream, you know, split it by the state that it's in, and then show me a chart of, you know, what state it's in per day over time, and then, you know, how does that change over time, something like that. Yeah, it's very common.
Okay, nice. So is it, it's a ROS interface, right? So then it'll be like from the customer end, you would get ROS topics and then you plot them.
So we're actually ROS agnostic. So in our case, we have, you know, if I go into this, for instance, you know, so this spot that we have is actually, we're kind of a combination of ROS and non-ROS for different things. So some of these, you know, we can just add ROS topics and say, you know, we want to take the, you know, whatever, the fisheye image or something like that, and ingest it, give it a stream name like something like that. You know, we also do all kinds of things like video encoding on the device. We do on-demand data is what we call it. So you can leave data on the device until you want to pull it, and then you can manually request it, or, you know, an event can trigger the ingestion of the data. Lots of that sort of stuff. But yeah, so it's either ROS or, you know, we do direct hardware streams. So video and audio USB devices will automatically discover and just use directly, which also reduces latency a little bit as opposed to going through ROS for, you know, if you actually have something plugged directly in. And then we also have, you know, an API. So anyone who's not using ROS generally will use our Python SDK or our GRPC interface to send data to the agent that actually goes on the robots.
Okay, that sounds nice. Thank you.
Yeah, I mean, ROS, you know, it's actually like ROS is such a huge like bonus to this kind of work, because people can come in and essentially set up, you know, basically everything in like less than an hour usually, which to do sort of an integration from a robot to like a whole cloud platform is just like tremendously fast. You know, non-ROS integrations take maybe 2 days, something like that usually. I would say it's usually ends up being like a couple hundred lines of Python or something.
Yeah, that's true.
So if someone runs ROS and wants to use your software, do you deliver a package for them, or do you just fetch the topics directly and they don't even need to install your packages?
Yeah, so we'll start by having you install the agent on the robots. So this is usually something that gets done at provision, like when the robot comes off the line and is initially set up, it will sort of pull down its different packages, and one of them is our Linux package. So if we, wanted to add a new device here, you could install it manually also by just getting our agent, plus this is our provisioning token that we use to actually create the security credentials to the device. And then after that, we'll kind of wait until it actually gets installed, and then do the automatic provisioning. We can, in some cases, automatically discover ROS topics and configure it, but it's all pretty easy if it's ROS, realistically. And we do Docker also. A lot of people now, I'm not sure if you guys have seen it happen much, but a lot of people are running essentially all of their robot services in Docker containers at the edge. So, basically the robot will run, sometimes just one Docker container, but sometimes, a whole set of them. And then it's kind of a little bit easier to manage the, what code is actually running on the robots, because you manage it using the whole Docker infrastructure.
Nice.
The so a lot of the companies that I think have shown up in Weekly Robotics are actually also companies that we have been working with. And I think one of the interesting things about getting to work on the infrastructure side of things is that we get to see sort of really deeply into the autonomy systems and the infrastructure setups and sort of the whole internals, like software internals of lots of robot companies. And so I'm also kind of happy to answer, I think, if anyone has questions around how people are, who are at scale. A number of the companies we work with have, like multiple thousands of robots. How people are doing things, because I think it's something that a lot of it's actually really all over the place, and we've realized that I think that the industry hasn't really matured yet as far as figuring out best practices for doing these kinds of things.
Do you maybe have some examples of what some mistakes or things that people often do that are not really optimal for such deployments?
Yeah. So there are a lot. So one of the things we see most commonly that's, I think, really works people into a corner is that they will they'll kind of get off the ground by putting VPNs on robots, and then sort of having either one VPN that is for each robot that people can connect to remotely, or they'll have sort of one giant VPN for all the robots, and they eventually end up, as soon as their customers start paying attention, they kind of end up getting these systems in a lot of trouble. Because if you have a VPN to a robot and it's operating on your customer's Wi-Fi or something like that, you kind of have access to their internal network through your VPN, and ultimately, it's like a security problem for the companies that are doing it. VPNs have gotten a lot easier to manage more recently, but I think that the model that ROS works in, where it kind of works with networked services, kind of makes people start thinking, well, I should just make my remote control another network service, and then I should make my data storage another network service, and then I kind of have everything in this big blob of a VPN, and then they kind of can't move away from that to a real sort of more modern cloud native infrastructure. So that's one thing that we get called in a lot to solve those kinds of problems for people, because they realize they've kind of worked themselves into a corner. I would say another one that's pretty, kind of a constant problem for people is connectivity in weird environments. They kind of end up in situations where, they can, if you're on a farm or something like that, you might be able to walk next to a robot and have good connectivity to it. But as soon as you want to start operating it remotely, you have sort of like a completely different set of considerations. And so when people are in that situation, they end up realizing that a lot of the tools they developed to run the robots, in person aren't really going to be possible to use in any other environment. And they sort of have to shift both the type of control that they're doing and then also the type of connectivity that they're using. So one thing that is actually a very interesting situation is that the better an autonomy system gets, the worse your control of it can be to still, accomplish the task. So for example, Spot here does a really, really great job at obstacle avoidance. It's probably the best obstacle avoidance system I've used, besides maybe like the Skydio, like that drone back there on the wall. And what it'll do is you can try to drive it straight at a wall and it will just kind of turn and not hit the wall. So you can actually teleoperate Spot with 300 milliseconds of latency or something like that, and it's completely usable. Whereas most things that would make it completely unusable. But even if you think about teleoperating a self-driving car, as long as it has local autonomy that can actually take care of bad situations, pull over if it needs to, if it's always safe, then it sort of seems not crazy to teleoperate it. Whereas, if it didn't have an autonomy system, it would be like completely insane to teleoperate it like on the highway or something. So, the type of control, I guess what I'm saying is like, we see people essentially putting types of control in place for local operation that kind of don't scale to remote operation. But we try to make it so that, both are kind of, you kind of have all abilities available in both places, and then you can kind of just, pick what you want.
Yeah, can I go on?
Yeah, I was just going to ask, what kind of software do you see your customers running? So is it mostly like open source stuff with some of their own components, or do they kind of stitch together other companies' commercial stuff, or is it like fully homegrown? Like what do you see as the most common setup?
Yeah, it's fascinating. I think it definitely goes in stages. So, so many companies start out and it's just default ROS everything, sort of customized for their morphology. And then they, at some point realize, maybe I can get a localization system from some other company that's going to do a little bit of a better job, or maybe I can, add a computer vision system here that's going to do a good job at, some aspect of what they need to do. And they do kind of pull in a couple vendors for things like that. I think for most of the companies that we're working with, we tend to be maybe the vendor that kind of like the vendor that has the most impact realistically, because we have like a pretty broad set of things that we do for people. And so generally most other companies that we see, they tend to be like very specific, like one service that the system uses. I think that realistically, like I really wish companies used a lot more vendors here, but there's very strong culture of like, even if I started a company and I decided strawberry picking is all I care about, it tends to be the case that people are like, they want to build the whole thing themselves. And they consider lots of the stack, lots of different pieces of the stack, like very strategic to their business. They feel like it's hard to bring in external vendors.
Yeah, no, I agree. Yeah, it seems pretty crazy that some people would like completely reinvent stuff like localization. That's like, I mean, everyone has that problem. I mean, sure, there's like different flavors and stuff, and you might think like, yeah, your case is so unique that you really need to figure it out yourself. But yeah.
Yeah, it is. It is really. It is really the case that like I do think we're hitting a level of maturity now that even a couple of years ago kind of didn't really exist. Like where the there are people starting robot companies that are like, I worked in the farming industry and now I want to start a robot company and I want to buy everything and put it together and put it out there. And I think we need like so many more people like that, because unless those people are kind of doing that, then we can kind of make as many robots as we want, then it's not gonna they're not automatically going to be valuable, right?
Yeah.
But I would love to see a situation where there was sort of a huge like flourishing of different vendors that you could kind of select between. And I think that in general, like if you take one like popular ROS package and you were to say, I'm going to make something that's compatible with this interface and I'm going to start a company around it, and I'm going to make like a premium version of you know cartographer or like something like that, you probably, if it was like interface compatible, I bet you could find a lot of companies to sell that into, because the sort of like level of maturity is actually like starting to reach there. It's like only now happening, I think.
Yeah, and how much do you see of like raw stacks versus non-raw stacks? Is it like roughly, is it like 50-50, or is it like closer
Yeah,
to
it really is kind of 50-50. I think when we first started doing this, I was really hoping that it would be less 50-50, and that it would be like a more obvious, we should only focus on these guys sort of situation. But yeah, I would say it's very much 50-50, and people are really super adamant about their decision to either pick Ross or not pick Ross, with these like sort of giant wars that they fight between themselves. So we try to be sort of Switzerland, to maybe make a Kenneth joke.
Yeah, cool. Thanks.
Mm-hmm.
And do you see now an uptick in people wanting to use ROS2? Or what's the percentage you see between ROS and ROS2?
There's very few ROS2 commercially so far. So, we have a couple customers using ROS2. They tend to be kind of brand new companies that just started within the past, maybe 2 years, but maybe not even 2 years. And honestly, I think most of the time they tend to make the decision to pick ROS2 because it's newer, not because they have any sort of specific requirements that it serves better yet. But they sort of expect like, well, we'll get on the new one now so that we're more future proofed, which I don't think is a bad idea. But I think that it hasn't quite been the case that for sort of production use cases, like ROS2 has something that's like, that's the one we need instead of ROS1. So the other really common thing is to just use gRPC. So gRPC is Google remote procedure calls, and it's essentially, you use protobuffer message types that can generate code stubs in lots of different languages. And then, you kind of have every service can talk to every other service. There is a streaming gRPC capability that lets you basically subscribe to topics, kind of like ROS, realistically. And a lot of people, like including Boston Dynamics, they're sort of all about gRPC for robot communication.
And maybe I have one more question. I have more actually, but do you have some maybe tips or ideas on measuring latency, which just use something very simple like built-in tools or some services for checking latency, or have you just figured it out in your stack and you're using some methods?
Yeah, so there's a couple things. So latency is one, but jitter is also super important for your ability to actually teleoperate. Jitter is sort of how sort of on tempo are the frames that you're receiving if you're using video or controls that you're sending if you're controlling something. And people, if you watch people teleoperating with high jitter, even at the same latency, they do much worse because the jitter really makes it hard to tell how fast you're going and like all these sorts of things. So the first step to all this is measuring it all. So we make sure to kind of collect data on real world test cases. I mean, luckily now we're at the point where this spot it's been sort of all over the Bay Area, like in the woods and in mines and in falling down hills and all. I think this is actually our fifth spot. I think we broke 4 of them previous to this. And this one actually just got its feet replaced yesterday. So you guys are dancing with fresh feet today. So we do a lot of our own testing, but then we actually, now that we have a lot of customers that are sort of using this on a day-to-day basis, we can collect statistics from the field and then see, in these kinds of environments, it's sort of one way, and in these it's another way, and then start to optimize around that. So we tend to go pretty deep with customers when they're teleoperating in new connectivity environments too. So, they'll start out and be in like a hospital or something like that. And for the first, few months that we work with them, we'll sort of be on a pretty tight loop of trying to optimize, if they come up with some issue, we optimize around it. And I honestly, I think a teleoperation system is one of those things where you just need like track everything super well, be really rigorous about it, test it like relentlessly, and then, put a million different little considerations in place for different situations. So this not like an easy answer, I guess.
One question. So for our robot, it makes sense to keep. We had KPIs such as where does a robot greet people, for example, in stores. So our robot was in stores, greeting people, guiding them to where they could buy their stuff. And we wanted to see what type of people, what age and gender of people was the robot greeting at what locations in the store. How would you set that up with Formant, and how hard would it be to set something up like that?
Yeah, so that's pretty similar to what a number of companies, I mean, so imagine those things are grapes and you're scanning grapes and counting them or something like that. It's like pretty similar to a lot of situations like that. So basically where it starts is that we have you upload a telemetry stream that has, either every single grape you scan, you upload, or maybe you upload in this frame has, 50, and then this frame has 40 new ones, and then this frame has 30 new ones, and you can tag them with types, things like that. And then based on all of that, we would put together an analysis board that would show you, here's the categories that you have, and here's how they change over time and all that sort of stuff. So yeah, it's pretty common use case.
Okay.
And also with this, we pass it on to your other systems. So if you want to use Jupyter Notebook or whatever, you can do that too.
Right. Sweet. Thanks.
Yeah. I should also say, this is the sort of default view here, but one thing that we've been doing a lot more recently is doing white label deployments for sort of robot OEMs. So you can take this and say, this is if you are a company that sells a robot, we make it so that you can basically sell like a full cloud platform with the robot that you're selling, and it's branded, Boston Dynamics or whatever, but it's actually Formant in disguise.
When your customers are scaling from like number of robots, say from 10 to like 100, what are like the main challenges they generally face? and what do you exactly help them with?
Yeah, so when you're scaling, it's really looks like this is disconnected now. When you're scaling, it's really becomes a unit economics question. You know, as you start to get really big, it changes to being you know, the question kind of changes to being like, can I get these robots to work? To be like, okay, like, you know, for this autonomous floor scrubber, it's gonna cost me $500 a month in, you know, support costs for my remote operation staff. It's going to cost me on average of $250 a month for a service. I have to fly somebody out there once every 2 months on average to fix something. So that's going to cost me this much. And you really end up making basically a big spreadsheet with what are my costs and how much am I making from it. And then you really just start to try to hammer your costs down because that's, you know, where all your money comes from as a company. And so you know, you end up in this situation where like cost of support is really hard to scale well for a lot of people. So what we try to do is we try to make it so that as you're scaling, you know, your cost of support goes down and down and down because you have fewer people necessary to actually like support the sort of high scale. They have faster workflows. You know, you have sort of essentially it's more efficient. So that's that. I think, you know, at the low end, it's really like a time to market value proposition where you can get to market, you know, really quickly because you have everything off the shelf. Then on the other side, it's really like unit economics at scale is the value proposition.
Hey, James.
At
I just
what
have
time sorry.
No, go ahead, please finish.
Sorry, I just wanted to continue to the previous question. So at what time do you think it's a good number? So what should be the fleet capacity for us to actually invest into actually making such a, like invest into having such a nice fleet monitoring system? So because with 10 robots, I don't think you could probably just manually do it. But then when you're going to 100, so what is the optimum number when you should actually transform into this fleet management system?
Yeah, I think the optimal time is really essentially as soon as you decide that you plan to have high scale, right? So if you're building a business where you're just going to sell robots or you're going to sort of operate a small scale, then I don't think you really, you know, I mean, maybe it helps to worry about this, but it doesn't help tremendously to worry about it. But if you're planning to reach high scale, then I think it's really like a lot better to kind of think about these things early as opposed to later. We actually, you know, have like ways to make it like extremely cheap for startups, where we just basically meter some of the data ingestion, and you know, you pay like a couple bucks a month per robot. You know, if you're sort of below a certain scale, then it's generally very easy. So we get a lot of people who kind of come in and they're sort of in prototyping phase. They don't have it's actually useful to see the data from the robot. It's useful to test it and teleoperate it and control it. But it's not like they're in production yet. It's not like they're even doing pilots yet. But they still sort of set everything up just because it's kind of makes it faster to do development. And, you know, they know that they're going to need it later. So they might as well sort of start getting used to it.
Thank you.
So, but we have tons of customers with like 10 robots. That's very, very normal, sort of time that people come to us.
Hi, James. Yeah, this is actually extremely amazing, and also like all the amount of detail that and the scales of detail that you can like see and interact with. I just have a question, just curiosity. What happens if you have a fleet of robots that's, let's say, going to operate more on zones where, let's say, Wi-Fi is not so much available, or internet? Like how would the interaction with the software and the robot fleet be?
Yeah, so what we'll do in that case is what we call kind of black box mode. And this is mostly like a data recording mode. So, you know, essentially we have two disk buffers. Here we have like a sort of a standard upload buffer and then an on-demand disk buffer. And you can pick per stream whether it should, you know, automatically flow to the cloud or flow to the on-disk buffer, and then you have to sort of request it before it goes to the cloud. But, you know, the disk buffer you can set to like 100 gigabytes. and then run the robot for a week. And then when it gets back to Wi-Fi, it'll sort of upload everything automatically and synchronize all the configuration, all that kind of stuff. And then, you'll be able to go back through and have the timeline view and, see what happened when you were running it.
And
so there's a lot of that too.
For example, I mean, if the robot goes into some kind of trouble and, and there's no connection, like how, I mean, is it?
Yeah, for teleoperation, you can't do much. You can't do much about it. So yeah, you have to, yeah.
So basically the robot will, let's say, will be kind of lost in that situation.
Yeah, so normally what happens is people set up systems so that if they're out of network connectivity for too long, they like return to a home point or something like that, just because, I don't know if you've used a lot of, modern like consumer drones, but if you take like a DJI drone and you fly it up and you just fly away with it, it'll eventually lose connectivity and then just come back to you. And so it's a good way to do it.
One question about the teleoperation and safety. Do you have some mechanism in place there? Because I think there's often safety involved in teleoperation.
Yeah, absolutely. Yeah, absolutely. So, a couple things. So one is that, if you come to us and you say, I want to, teleoperate a, wrecking ball through downtown New York and do it manually from my helicopter or something like that, we're going to tell you like, no, you can't do that, right? Like, so some things I think are just fundamentally unsafe, and we make sure that we actually know what people are attempting to do, and we're kind of working with them. So when it comes to sort of things that are safe, I think that the first priority is that you have to have some local autonomy that's capable of making safe decisions should it be disconnected. There's a huge difference between self-driving cars and like literally everything else, because with everything else, if you get in trouble or you get disconnected or whatever, you can just slam on the brakes. Basically, everybody can just slam on the brakes and they're completely fine. Self-driving car, you can't do that. Maybe some forklift situations you can't do that, but in general, like you can just kind of slam on the brakes. So with our teleoperation system, we just make sure that the second there's an issue with, control or connectivity or anything like that, we have, not second, like millisecond, you'll get a message to the autonomy system that says, we have disconnected, so go into recovery mode or whatever you need to do.
Do you have any kind of devices that you connect, actual hardware devices for the teleoperator, so he's in control? Because with this browser, then I guess there could be some issues where you don't know really if the user is able to actually shut off the robot hitting an e-stop or something like this.
Yeah, I think it's really important to always consider that the e-stop you're going to have is like maybe you get an e-stop, right? Like it's certainly the case that you might unplug your controller because you tripped over it, and then you don't want to drive into a wall or something, right? So what we'll do is we basically tell the autonomy system exactly what's going on as far as we know with the teleoperator, and then it can respond to that situation. So just being very fast about that. It means that everybody kind of has to make the right decisions about setting up their own system, but we provide the sort of high performance backbone for like that communication. So and I should mention we also do a lot of external joysticks, and I have like those flight controllers back there that we use for a lot of things, and it's really fun to drive spot robots around with a steering wheel, which is like a little strange, but it's pretty fun.
Thanks.
Yeah.
Yeah, maybe an additional question on privacy. With all the video you get into to the system of people and so on. Do you have any mechanisms in place to kind of anonymize people or things like this?
Yeah, so we've done it for individual clients. Basically, you can run an anonymization service at the edge that scrubs all the incoming, video of people. I might even have something like that in here still. Maybe. I think the data is gone. But yeah, so you can do it at the edge, scrub people. You can also do it on the back end. But in some situations like that might be a HIPAA violation, things like that. Teleoperation doesn't stream any data to the cloud, so you can actually make it so that someone can still operate a robot, but you're never actually capturing images and storing them. So that's one way to get around it. Like ultimately with a lot of these rule sets, if you don't actually have the ability to identify people, or you don't have the ability to look people up or say, find me a picture of this person, or who is this person I found a picture of, or, there's no capability there, and you delete the data in time, and, there's sort of a set of things that you do like that. In a lot of cases, it is actually not necessarily illegal to capture pictures of people and store them on a server. But it's something that I think changes depending on the environments. A lot of times customers will have certain requirements, like, Walmart will say, you are not allowed to take pictures of my customers and upload them to your service, right? So then their service providers need to deal with that. But yeah. So for us, we just try to make all of that easily configurable. So data retention, sometimes storing data on the robot and not uploading it, things like that.
James, do you have anything else planned? Because I don't know if I should go with my favorite question or not. I don't know if
No.
this is the right time or not.
No, that's I'm ready.
Okay, so did you have any mind-blowing show or anecdote related to robotics that you could share?
Well, I think I'll give a general anecdote that really I think is like something I've seen over and over and over again with like a lot of my friends who do this kind of stuff, that is something to like really internalize, which is very frequently I've seen this pattern where someone comes out and they grow up and they want to be a roboticist, and they go to college and then they do a PhD and they specialize in some form of robotics that is really really cutting edge, and it is what they want to be doing. And then at some point they decide, I want to start a robotics company based around this technology that I've created. I had a friend actually, he started Bossa Nova Robotics, which I always think of him like when I think of this, because he started with a ball balancing robot, this really amazing ball balancing robot that is a big stick, sits on a ball, and it kind of drives around, with balances. It's so cool. And you then take a robot like that and you say, I want to start a company. And then eventually you realize, well, I think what people are going to use this for is scanning shelves, because it's very tall. It can go around people, easily. It can follow a path. It can, can do this sort of whole thing. It's perfect morphology for it. And then fast forward 2 years, and now you have something that looks like a vacuum cleaner with a stick on it, driving around scanning shelves, and your whole life is about scanning shelves. And that's what you should care about, because now you run a shelf scanning company, not really a robot company. And I think that I've seen this over and over and over and over again, where people kind of come in with the really advanced technology side of things, but the fundamentals of the businesses that can actually use these things is sort of like not the initial piece. And then at some point you realize like, wait a minute, my whole life is now, you know, thinking about sewer systems, when in actuality, what I was really interested in was, you know, some sort of like crawling on the underside of pipes or something like that, right? And so I would just say, you know, if you're thinking about some specific technology, you want to make sure that you're kind of, it almost like, as much as I'm a technologist and I love specific technologies, I almost feel like it's a little bit backwards to be really very focused on that. And that I think we need so many more people thinking about this question of sort of, how do I automate this task fully, assuming that I can get good autonomy eventually, you know, and kind of combine it with remote operation and all this kind of stuff. And I think if you start there, then the morphologies of the systems and how they work and everything kind of fall out of it. But so I think that's my anecdote, is over and over and over again, these, you know, these sort of life stories where you're a, you know, an amazing roboticist and then you end up like just thinking about cleaning floors, and that's your whole life, you know, after a point.
That's very, very interesting. So you would say kinda that instead of thinking, so if I have a robotics company, so if I make robots that deliver food to people, I actually shouldn't think about building robots to deliver food to people, but instead I should focus on delivering food to people, and then robotics might not be my only solution.
I would say that
Or
oftentimes, yeah,
overextending
I mean,
your thinking.
I think you basically are, you know. I mean, I think a number of these companies that are really successful at their robot programs have started with, you know, I'm going to deliver food to people, like DoorDash, for instance, has actually a really great robotics program now, where they have, and Postmates too, where they have these, you know, delivery robots. They built a network of people delivering food, and now they're like, cool, we can invest an infinite amount of money in turning robots into, you know, something that can deliver food. Whereas if they started with, I want to make a robot that can deliver food to people, then you need to figure out who's going to buy it and what they're going to use an app, I guess, and how does it know where the food is coming from, and all of this kind of stuff, right? So, so I would actually say like the sort of scaling piece, I think, has to be built in from the start. And sometimes, you know, it's either a very, very simple robot system that you can start with, or it's something that's, you know, pretty manual, and then you automate over time.
Yeah, it's very, very interesting approach. Thanks for sharing.
Absolutely. Yeah, well, thanks for, you know, taking the time, guys. And you know, happy to chat with anybody more if they're interested, and, you know, can reach out to me. James@formant.io is my email. But I'll also be on the weekly robotics Slack if you guys are on there. So.
Are you planning to run the display with spots anytime soon as well?
You know, so when its feet started being an issue last week, or I guess beginning of this week, we took it offline, which actually, you know, coincided with when you sent out the link. It was like later that day, it like actually went offline. But I think the plan is to have it online next week, if they can actually get it back together. It seems like it's still down right now. So.
Cool. When you have it up, let me know and I will share it in the newsletter. Cool.
Sounds great.
Unless you don't want me to because you are afraid of Spot losing its legs again.
No. I mean, honestly, we're planning to grind this spot into the ground and then get another one, and, you know, just keep going, right? So that's how it is. We'll be out there. Yeah. I think actually we have a few more things like the Play with Spot coming online too, where I think Jeff has something he's doing where you can control He does a modular synthesizer music, and you can control his modular synthesizer remotely. And then I think he has maybe a photography one where you can take pictures of something remotely with like an arm and camera system and all that kind of stuff. So yeah, a lot of fun stuff coming up. So I'll keep you posted.
Right, thanks a lot. And thanks for the presentation. It's really good.
Thank you. Yeah, well, take care, guys.
Thanks, bye.
Thank
Bye-bye.
you. Bye.
Thanks. Interesting.
Bye-bye.
Thank you. Thanks. Really, really good presentation. Thanks.
Thank you.